Hi everyone, welcome back to the channel. In today's video, we're going to explore two of the most essential data structures in Python, lists and sets. These structures act as containers that hold data, and understanding them is crucial for writing efficient and clean Python code. We'll not only cover what they are but also when to use each one and how they behave in different situations. By the end of this video, you'll have a strong understanding of each of these collection types, and you'll know exactly how to use them in your projects. Let's get started. I've created additional tutorials on various Python topics, which you might find useful. If you're interested, please check out my playlist to explore these resources and quickly get up to speed with essential Python tools. You can find the link above and in the description below. Let's begin with lists. A list is one of the most versatile data structures in Python. It's ordered, which means that the items you put in a list will stay in the same order unless you manually change it. Lists are also changeable, which means that you can modify them after creation, adding, removing, or updating elements as needed. And perhaps one of the most important features is that lists allow duplicate values. To put it simply, a list is like a dynamic array that can grow or shrink in size. You define a list by placing elements inside square brackets. For example, let's create a list that contains some numbers and strings. This list contains a mixture of integers, strings, and a floating point number, and that's one of the advantages of Python lists. You can store different data types in a single list. Each element in a list has a unique index. In Python, indexing starts from 0. This means that the first element is at position 0, the second at 1, and so on. To access elements, we use the index like this. You can also use negative indexing to access elements from the end of the list. For example, in the console, you'll notice that it outputs the last element. Lists are mutable, which means we can change them. Let's say we want to change the second element in the list from 10 to 20. In the console, you'll notice that it outputs. We can also add elements to a list using the append method. See the console. And if you want to insert an item at a specific index, you can use the insert method. In the console, you'll see that the output array includes the element we just inserted at the second index. Removing elements from a list is just as easy. You can use the remove method to remove a specific item. If you want to remove an element by its index, use the pop method. This flexibility is what makes lists a go-to data structure in Python. But keep in mind that lists allow duplicates, which means you can have repeated elements like this one. Moving on to sets. A set is a collection that is unordered and unindexed. Unlike lists, sets do not allow duplicates, meaning every element in a set is unique. This makes sets particularly useful when you want to automatically eliminate duplicate values. Here's an example of a set in Python. As you can see, the duplicates 2 and 4 are removed automatically when the set is created. Sets are defined using curly braces, or you can use the set constructor to create an empty set. Since sets are unordered, you can't access elements by index like you do with lists. However, you can iterate over a set using a for loop. The order in which the items are printed may not be the same as the order in which they were added, because sets are unordered by nature. Although you can't access set items by index, you can still add and remove elements. To add an element, use the add method. To remove an element, use remove or discard method. The discard method will remove the element, but it won't raise an error if the element is not found. Sets also support several mathematical operations, such as union, intersection, difference, and symmetric difference. These operations are useful for comparing sets of data. Let's take a look at how they work. Union combines two sets and returns all unique elements. Intersection returns only the elements common to both sets. Difference shows the elements that are in one set but not in the other. Symmetric difference returns elements that are in either set, but not in both. So, to summarize what we've covered today, lists are ordered, changeable collections that allow duplicates, making them versatile for storing a range of data. Sets, on the other hand, are unordered collections of unique elements, making them ideal when you need to ensure no duplicates in your data. If you found this video helpful, please give it a thumbs up and consider subscribing to the channel for more Python tutorials. In the next video, we'll be covering tuples and dictionaries, so be sure to check that out as well. You can find links to additional resources and related videos in the description below. Thanks for watching, and I'll see you in the next one.